Hello, and thanks for using TickBoom. In this video, I'm continuing to work through the Board of Studies 2020 Extension 2 trial paper. So I'm going to work through systematically all of the 16 questions on that paper. I've already done a video where I worked through question 1. So in this video, I'm now going on to question 2. So question 2 says to consider the region described by the following inequalities over the complex plane. So we've got z plus z bar less than or equal to 0 and negative pi on 6 less than or equal to the arg of z plus 1 minus I less than or equal to pi on 6. And we're still in the multiple choice part of this exam. So we've got these 4 options. The area is either 2 on root 3, 1 on root 3, root 3 or root 3 on 2. So what I've done here is I've just written up the 2 inequalities that we're told and the 4 options we've got to choose from. I think the natural way to tackle this question is to look at each inequality one at a time and then plot up that area in the Argand plane and see if it ends up being something that we can work out the area for. So if I start with z plus z bar less than or equal to 0, I think we should start by letting z equal x plus iy, just a classic complex number. So z bar would equal x minus iy, the conjugate. So z plus z bar would be less than or equal to 0 when x plus iy plus x minus iy is less than or equal to 0. These two cancel. So we get 2x less than or equal to 0 or x less than or equal to 0. So that's going to help us. We're basically, when we draw up our Argand plane, we'll just be going left of the imaginary axis, just the negative real values. For this, I think it's going to be helpful to think about the argument visually. And I think if we can get this in the format of one complex number minus another, then hopefully that's something you're familiar with in terms of plotting that up in an Argand diagram. So if we think about z plus 1 minus I, that I'll just do a simple rearranging to say that's z minus negative 1 plus I. And I'm just going to call that z minus w, where w is the complex number negative 1 plus I. So we can plot w in the Argand plane. So I think that's kind of all we need in terms of ingredients to now draw up what we're dealing with. So I might just put my Argand plane over here. So we'll just have our real and our imaginary axes. This x less than 0 means we're really only concerned with here. But what I might do first is I'll just plot up, maybe I'll call this negative 1. I'll call this 1. So if I plot up point W, that's going to be negative 1, 1. It's going to be this point here, point W. And if I think about z minus w, so if we have kind of this line here, and we have some point z, then this line would represent z minus w. And if I just plot a line that's parallel to this real axis, this angle here is the argument of z minus w. So we're kind of told this argument has to be between pi on 6 or 180 on 6, which would be 30 degrees, or negative 30. So actually we can think about kind of z possibly being down here too, because we could also have essentially 30 degrees or negative 30. I'll just write this as negative 30 degrees. Essentially same magnitude, just coming the other way from the horizontal. So because we're only concerned with x less than or equal to 0, really the area that we're looking at is this triangle here. And I think if we think of it as two right-angled triangles, I think that's going to be quite easy to work out the area. So I might just draw these triangles here. We've got a triangle. So we've got this triangle here, so there'll be 90 degrees, 30-degree angle here. This, we've come back 1, so this has a length of 1, and this is some height h. And for completeness, I'll just draw the other part of the triangle. So this is also an angle of 30 degrees, just coming the other way, same length of 1. It will also have the same height of h because it's the same angle. So essentially, if I use SOHCAHTOA, I can say opposite over adjacent. So tan of 30 would equal h on 1, or just h. So basically, the area that we're concerned with, this area of the region, is going to be equal to double the area of one of these triangles because they're kind of identical triangles. So it's going to be 2 times, and the area of this triangle is a half times the base, which is 1, times the height, which is tan 30. These 2's will cancel, so the area is equal to tan 30, which hopefully you recognize as being 1 on root 3. And just to test that, I'll just get my calculator. So if I did tan 30, I get this 0.577, and if I did the square root of 3 and took the inverse, I get the same thing. So that just kind of confirms that tan 30 is 1 on root 3, but hopefully that's just something you've committed to memory. So if I look at our options, that's option B here. So that's the answer. Option B is the answer. So hopefully that's been easy enough to follow along. I think this first inequality, very straightforward to deal with. I think the second one, the key to it was, well, at least for me, there was probably a few ways to tackle it, but for me, I'm quite a visual thinker, and I just thought if I know how to draw z minus w in an Argand plane, so let's make this z minus something, and then it kind of fell out pretty neatly from there. So I think that ended up being a good way to go. So yeah, hopefully you found that helpful, and tick boom.